Hello, everyone. This is part zero of a playlist that I'm making that covers my undergraduate math project. I thought it was pretty interesting, and I kind of always had the idea in my head that I was going to make a YouTube series about it. I did it about a year ago. I'm a math major, and I think it'd be pretty entertaining. If you're like me, I watch math videos on YouTube for entertainment, so hopefully I can take this and contribute back to the community. I've learned a lot from a lot of math YouTubers like Khan Academy. I think it's Patrick JMT, Vsauce. I didn't even spell it right. Vsauce and Viart. People are inspiring individuals. There's many more. I will link to these channels in my. There's a section of a YouTube channel where you can link to a bunch of channels that you recommend. But I've never seen any of these maybe I missed it, but I've never seen any of these channels talk about all of this in particular. And what I want to really get to are these two theorems right here. Faulhaber's formula and the Euler-Maclaurin summation formula. Both of these formulas are extremely interesting. And I think if a high schooler went and watched these videos and they followed along, they could understand maybe not how to prove these things, but what they mean and why they're useful and why they're interesting. And all of this is basically math from a bygone. Well, it's not bygone. This is all very interesting and still useful today. But a lot of this was developed, I think, in the 1600s and the 1700s. So I'm going to make the video series. I already uploaded the first part, which has to do with summing 1 plus 2 plus 3 up to n, and what the general formula is for that. Faulhaber's formula tells you how to do that for numbers raised to any integer exponent r. There's a general formula for this. And the Euler-Maclaurin summation formula can use integrals. If you don't know what that is, don't worry, but it can use integrals to approximate these things, and vice versa. So it's very useful in computers and getting accurate representations or accurate approximations for series that converge very slowly. I'll show you an example of that. I'll actually show you a coded example of that. But before we can do all that fun stuff, we need to talk about a few things. So the first few videos are going to be on combinatorics, which is a fancy word for counting, which is counting is more difficult than you might give it credit for. I will show you how. It's not that difficult, but there are some fancy ways to count. Discrete math. Calculus is usually concerned with the study of continuous functions. We will not be talking about continuous functions in the discrete math section of this because they are discrete. They are not continuous. We'll talk about summations. If you've ever seen this symbol before, if you haven't, don't worry, I'll introduce it. Everybody should be familiar with polynomials, like a0 plus a1x plus a2x squared, ... Those are polynomials. And we're going to show a lot about these interesting class of functions, which I define like this. Sigma sub r, this is the function, sigma r of n is equal to 1 to the r plus 2 to the r plus 3 to the r plus ... up to n to the r. And I will show you that this is a polynomial of degree r plus 1 in n. And we're even going to get even more cool at this. This was actually, when I was doing the project, I didn't intend for it to go down this road, but I found something that was so interesting I couldn't go without it. I thought of a new function. I call it psi r of n, which is the sum of the sigmas from k equals 1 to n. These are actually interesting, and somehow they pop up, and right now you might not even, it might not even like be clear to you what this means, but It's actually pretty interesting, and we'll probably get there maybe about like the 7th or 8th video. But anyways, I just wanted this to be a short introduction about what this playlist is, and I hope you enjoy it.